So today we're going to be working on distance on the coordinate plane, and we're trying to incorporate school theme of wave, writing, written and verbal evidence. We're going to write and we're going to speak with thought, with sense. All right. So our goal today is to create and solve distance problems by using the coordinates and absolute value. So but before we do that, we always have something like we think about, we share a little out of math context. So let's see on how you could connect this to your personal thought. What makes a star, or what makes star a star? I'll give you a minute. Let's start with Alana. Go ahead.
Possibly you consider that being like a star student, doing getting really good grades, by being a movie star, being the main character in a movie. But you could consider yourself a star if you do something that you're proud of, and then that could make you a star. You don't have to be someone the whole world knows and considers you a star. If you consider yourself a star, that's all.
That's correct. Omar, go ahead.
Uh, something that makes a person a star is that when they respect their parents and follow rules, someone that cares for others and give up their time to help, a person that follows their dreams.
That is so nice. Anyone else? One more share? Anyone else would like to share? That's it. Okay, Selena. One last share.
A star is a star by being themselves and having their own talents and like helping people and being kind.
See, you guys are good in connecting, even though this is like just a star in my other class. The star is a star if it's yellow. I say, yes, that's true. That's like you could see who are connecting to reality and who is just literal. So, but you guys are deep. You have some thought of real sense of real life, which I'm so proud. Okay, so with that said, let's move forward. So today, I'm just gonna create an example of what will be the wave task that we have. So we're gonna work at it together. So our goal is to create and solve distance problem by using the coordinates, right, in absolute value. So at this point of time, I'm gonna ask you to create a word problem based on this scenario. This is the fish. I don't know why she's so happy having the hook in front of him, but create a word problem that says a distance from the hook to the fish. It's up to you how you're gonna create them. Just make sure it's realistic. The fish will not be above the seawater. They are both under under the water, so they are both um under the sea level. They should not, it could not be next to each other. It could be up and a little bit down. It's just the idea that the hook and the fish. Alana?
So if they're under the water, do they have to be in negatives or no?
They should be they could be on quadrant 3 together, or they could be in quadrant 3 and 4, or they could be in quadrant 4 together. It's up to you where they are.
Oh, so it has to be in quadrant 3 or 4, not 1 or 2?
You can't have those fish in the hook in quadrant 1 and 2. You know why?
Oh, yeah, because it's above sea level.
Okay, got you. All right, so create your word problem. Make it simple, straightforward, and realistic. Realistic, not unreal. Like it looks like true problem. I'll give you 2 minutes, okay? Mr. Spisha has shown me something here. Yes?
Does it have to be like realistic in real life, or could it be like something based off of the cartoon drawing?
You could make it based on a cartoon one. I don't have that. What he got? He has this icon in the bottom that says timer. So, anyways, I'll figure that out. All right. So 2 minutes. I'll let you do work. All right. Let's start to show some work. All right. So here, that's why you're just editing them. So Mr. Fish fell in love with Miss Worm. They're going first date. You really creating a story. They are at -2, -4, and they're planning to have their date in a Coral Reef Cafe, which is 3, -4. What is the distance from that? That is a very fancy one, but I like it. It's a story. Next. So Mr. Orange Fist goes to meet the worm on the hook daily to try to save him. Really? That is so funny. The worm is found in -4, -3, and the fish is at now whatever you're editing it for -2. How many meters does the fish have to swim to meet the worm? 1 unit is 1 meter, or so like one block is 1 meter. That's a good one. One more problem to read. The fish is below sea level and is trying to caught by a fisherman. The hook is some distance away from the fish. The coordinates are -1, -6, and the coordinates of the hook is instead of doing that, you had to write parentheses -1, comma -6. Instead of doing the coordinates are, you could put them like this one in a parenthesis form, like this. Okay? So that's how we really plot the points. Okay, one more problem I'm going to read. Here, you need to put this in parentheses. The coordinates of point D is at -3 and 2. And the coordinates of point A is a -3 and -4. How far away is the point D from point A? You had to really mention the fish and the hook. So if you said your hook is at you could say the hook and the fish. All right, you have to be specific. Based on create a word problem based on the given scenario. So instead of point A, you say the location of the fish and the location of the hook. That is cool, guys. With that said, I'm gonna open student page for this so that you could go back and check your word problem for our next task. The next one is you're gonna solve, but this time I want you to use absolute value to solve the problem. So you're gonna replot your points over here, and you're gonna show work here using the absolute value from your previous answer or previous problem. And then when you're done, or you're quickly done, I'm gonna go right away to slide 6. You're gonna explain with the use of the wave. Remember, the wave is written on verbal evidence, okay? I really want to hear or see that you're writing the distance between this and this is 5. I did that because I need to find something like that. Or I subtracted the distance from the fish to the hook because they are in the same quadrant. Whatever your reason is and how you find your answer. Question. So what we're making right now is an example of the task that you're going to be working on in a few minutes from now. Omar.
I still don't quite understand how to find distances between two landmarks or areas.
Did you go back to lesson 2.5?
I didn't go back there, but then we did the review thing, I remember, before the test.
All right, so I'll work with you in a moment. So I'll work with you on how to do it, okay? Anybody else got question? So with what Omar is asking, let me just show an example. So let's say, let me get my pen. So let's just say, for example, the Omar, you go, okay? So let's say, for example, the hook is here. So that's the hook, and the fish is here. Guys, like limit your distance just to the horizontal and the vertical line. So it's a straight line. So that's your fish. All right. So with that said, the coordinate here, Omar, is -3 and 0. No, the word that's not 0. That's not on the axis. That is -1. And then the coordinate of the fish is -3 and -4. What did you notice, Omar, about the coordinates? What did you
They both have -3 as their y coordinates.
So they have both -3 as your x That's xy,
X.
xy. Okay. So both -3 and -3, it means they are on a straight vertical line, correct? So it
Yes.
means we're just going to find the distance between here and here. But since they are on the same quadrant, we're going to subtract the absolute value of the y. So the absolute value of -4, we'll take the bigger number so it's easier for us. There's no negative numbers. And -1. So we're looking for this distance, right? But remember there is space here. That's what we're taking. We're subtracting it. So 4 minus 1, you're going to say 3. And if you say, like Alana said, that this part 1 is 1 meter, so you could say that is 3 meters.
What if the x-axis is different?
All right, then let's try to do that. But this one is clear, so let's
Yeah,
try.
I got it.
All right, let's try to do that one. So let's say it's, but you cannot do this with the fish, okay? Because the fish in the hook is under the water. So just for the sake of you asking me, so let's say house number 1 is right here. Then house number 2. Oh, you want it here? Since it's a house, it should not be under the water.
Yeah, it could be, but it just has to be a different
Quadrant.
axis.
Okay, so quadrant, just an axis. So other house is here. So that's the other house. Okay, so what is the coordinate here? That's -3 and 2. On this side, that's 2 and 2. Let me change that so you will not get confused. Let me change the coordinate to a number that is not the same. So I'm gonna put it here. All right, so the coordinates for that is 4 and 2. So not anymore 2, 2. What do you notice for the coordinates?
The y-axis is the same.
Okay, so the y-axis is the same because they are in the vertical line. I mean a horizontal line. So it means we're going to find the absolute value of -3 plus the absolute value of 4. Because they are on different quadrants, you are going to find the distance from here to here and from here to there. So this distance plus that distance. All right? So that's
Okay.
3 and that's 4. So that's 3 plus 4. So let's say we're talking about each of this is 1 block. So you could say 7 blocks. That's it.
Okay.
You got it?
So you recorded this video. So is it gonna be in Google Classroom?
Yeah, I'll post it in Google Classroom.
Okay.
I'm saving this for those people who are absent, but I'll put it in so that you could go back. All right. So you guys, I give you 1 more minute to solve it. Did you see how we solve it? So you're good. So you guys already have tried to solve the problem. So absolute value of -1 and absolute value. So here you need to have only 2 spots.
Wait, what if I don't
how
have
come
to use absolute value?
Why don't you? Okay, you answered that question. Why do we need to use absolute value?
Oh, I thought we were solving our other problem. Oh God.
You're solving your problem. And
yeah, I'm solving my problem, and my problem doesn't need absolute value.
But why? Where's your fish? Above the sea level?
No, my fish is down there. And then I'm just finding where the worm is located because it is a mirror across the x-axis.
Look at this one. The worm is here and the fish is here. You're looking for the distance between the two.
Okay, I'll change it. I'll change my work problem.
No problem. Go ahead. And then let's see some explanation that you guys got. So here they are because, well, I don't know what happened here. The worm below it is 3 inches because of the difference. Plot the point so we see it, or the coordinate. The distance to the orange fish travel 8 meters. So you guys need to plot again and solve. So the only thing I would like to hear in the explanation is I subtracted because I did this because, and I really want it to be realistic. Like it's real. You don't really say that the fish is like 10 meters above sea level and the hook is coming to the fish. Um, the fish and the hook should be underwater. There is a way that the hook will be above the sea level because maybe the fisherman is just trying to put the bait to the hook to bring down to the water. So that's also a different story. Okay. So with that said, you guys could continue working in the Peer Deck or you could leave the Peer Deck for a while because you need to try to work on the task that I gave you in a Google Classroom. In Google Classroom, I have this. You're going to have the wave distance in action. So you're going to create exactly what we did in our example. So you're going to create a distance problem using absolute value. Here's the picture and there's another picture. So make sure you use a coordinate plane, an absolute value to problem. Use a scale if it is necessary to represent each blocks or units. You explain the one of the scenarios using the wave. You could plot your points here. You could create your scale and you need to explain. All right. The rubric is here. You create a problem, be realistic. You get 4 points for that. Numerical expression like the way you did absolute value O plus absolute value of this. So represent problem using the coordinate plane. You plot the points and you explain and make sure your work is neat, that is readable. Question? All right. So you have a question? You guys are your hands are you raise your hand. So is there any question?
I forgot to put my hand down.
It's okay. So if I go back to the assignment, I put here, I said, for the instructions, I said, you complete the task by the end of the day. Okay, just you may ignore that. You could do it until tomorrow. So you could use Kami, PDF Writer, or any apps that you could edit the file. You could download this paper and write over, take a picture, send it to me. You could also use Lucid paper. You just solve it in Lucid paper. Just make sure you do it organized. And then don't forget to turn it in by taking a picture or submitting it to me. If you're using Kami or Google, there are things there, or Google Hub, whatever is that one. Make sure you save it first as PDF. Do not send it to me in the link because I may not be able to open them. There are times I can, but most of the time I cannot. So play safe is just send it to me as PDF file. Okay. Question? All right, so I'll give you the time.
Could I print the sheet?
I'm sorry, Alana, go ahead.
Could I print the wave sheet?
Yes. So you guys could start working. All right. So I'll be quiet. If you need help, just pop in or raise your hand. Good luck, guys.